yeah, recorded, and then go back. Okay. Yeah, the recording going to be posted. Okay. And then let's go back to our course website. So later submission, I just mentioned, and welcome to our class. The course website visit as usual, and you need to submit your assignments, okay? And let's take a quick look of our syllabus. And also, if you want to download, did you see, then it's at the very top of this PDF file. There's a file name, then you can download it. So all of our files are also downloadable. And let's see, for the course syllabus, so the majority information, object-oriented programming, basically, you see in CS2, we already discussed quite detail, okay? So over here, we are not going to have some dedicated discussion, but all this semester of the comprehensive data structure and algorithm we discussed are going to use object-oriented programming, is it? So I will kind of review once we see any concept connected with object-oriented programming to help you review. And the major topic also listed here. So we are going to learn some new data structure, sets, maps. We're also going to learn sorting algorithm, not all of that, okay, because computer science program has a dedicated class called algorithm, and over there it covers more, okay, but we will cover quite a lot. And the binary search tree, probably part of this class, because one semester we kind of touch binary search tree. So you may already have some basic idea, but that's also one of the major topic in CS3. And based on binary search, we also have AVL tree. Okay, we are going to discuss. And we are going to have discuss hashing and the graphs. Okay, so a lot of useful. And we're also going to touch a little bit about algorithm analysis. Okay, so that's also quite useful. So class time, Zoom, everything already you know, and office hour I listed here. Okay, and plus the Zoom link you can also access. And as usual, and most of you already took CS2 with me, so you know my style. I'm pretty easy instructor, okay? So if you have any questions, concerns, even though it's very trivial, teeny tiny, okay, just let me know, okay? I'm very flexible, and I can do some adjustment to serve you good, because the whole point here for my philosophy is to serve everyone well, okay? So, but if you think I still cannot solve your problem, then you are also welcome to report to our department chair, okay, Dr. McAllister, and his phone number and email also listed here. And the learning outcomes, I also listed here. So with the progress of our class, we'll collect assessment to meet the learning outcomes. And as usual of your other class, I believe the same thing. The accessibility. So if you need special help regarding our lecture, regarding your assignments, especially your exam, is it? And the DSS on campus, they have phone number, and I believe they also have email. Okay, you can contact them to do some special arrangement for you. Okay, if you need extra help. And academic honesty, so make sure to follow university policy, okay? So professional, etc. And don't do plagiarism, okay? So cheating, so we already know this. And then the next is about respect to each other, okay? And through all these semesters, I taught at Seymour, all my students very well. Okay, I never see any single case about the harassment civility. Okay, so but let's keep this good trait. Okay, and the grading skill temporarily we arrange like assignments, 35% quiz, and exams. Okay, and the quiz mostly in session. Okay, randomly based on what we discussed. And the policy for makeup of the homework, later submission, it's the same. So if a later submission, every calendar day lose 50%. Okay, so try to stick with the due date. Of course, if you have some special circumstance and need the extension, let me know, okay, in advance, so that we can do some adjustment. Okay, and generally speaking, quiz not made up unless you let me know in advance. Okay, I will allow you to make up. And for exam, same thing. Make up exam, you need to notify me in advance. And also because our class is online, and the exam will be, open like 8 a.m. and close midnight. So you need to pick like 1 hour or 2 hour. You need to designate it that you will be responsible for that time period. You will be able to access the internet and complete your exam. Okay, don't start with your exam at 11 p.m. and then send me an email say, oh, Dr. Liu, my Wi-Fi broken and I cannot finish. That's I believe is an excuse. Is it? It's an excuse. You forgot your exam. Is it? You needed to let me know in advance if you cannot take the exam, because I already gave you the whole day. Is it time frame? So let's just try to follow this exam schedule. Okay, so once, unless you let me know in advance, oh, you cannot take exam on that specific day because you will be on a business trip or your family needs some special chores to do, then let me know in advance. Well, then I can do some special arrangement. Otherwise, if you don't let me know, then suddenly at night, at 10, at 8, then you send me an email, then that's your own responsibility. Okay, because you need to guarantee you will find a way to complete the exam. Okay, so that's the exam textbook as usual, and the final exam schedule, as always, we follow the university exam schedule. Okay, and I have the link, and you can check. And then the contents. So this week we will do a quick review of LinkedList. Okay, because this also going to be used a lot, the concept in tree structure, in graph. So we are going to do some quick review of simple linked data structure. Then we will move on to sorting algorithm, very interesting algorithm efficiency analysis, very basic, okay, because there is another dedicated class. But this will help you in some regarding, okay, especially if you want to look for some internship early, okay, this may help you. And then binary search tree, AVL tree, so tree structure, okay. Then set and map and hashing, okay, and the graph, and the weighted graph, and some secure coding and the local and the global impact. So that's the class syllabus, and the detailed information always available on our website. And all the examples will also be posted on our class example on class website. Okay, so that's the website and syllabus. Next, we are going to jump into our material. Okay, I needed to start. Hold on. Let me see which one I should start. Okay, it should be this one. I'm recording. Okay, good. Okay, so as our syllabus outlined, so we will start with simple linked list. Structure. And for linked structure, so a quick review. Maybe this is our first quiz question. So who remember for linked data structure, what's the basic building unit? Do you still remember what do we call something looks like this is? Anyone?
Next is a node.
Yeah, it's a node. Is it? It's a node. And a node has two parts. Is it? And what are the two parts for the node? Like I draw here. What's this?
One is value, another one is next address.
Yeah, so we call this part some information. Hold whatever information you want to store, is it? And over here, this arrow point to where? What's the type of this? And generally speaking, we learn generic. The information, the type, some generic type, is it? So that means it can be string, can be employee, is it? All sorts of type. And then what is this? The arrow. What is this?
It points to the next node in the list.
Yeah, point to the next node. So the type is what? Type is node. Okay, so that's the linked data structure. Is it? The very basic building unit is a node. Okay, a node has two parts, information, and another part is another node, the next node. We call it next. Is it? Okay, so that's a node. And then, so that's the first question. Oh, you then please send your answer to the chat and send it to me, okay, privately. And so that's the first quiz question, so node. And it has two parts, information and next. Okay, next. So this is the node structure. And for the linked list, is it? And here we call it a simple linked list. So a simple linked list, basically it's one-way linked list. Is it? One-way linked list, so it's kind of look something like this. So you have a number of nodes linked together. Is it linked together? So generally speaking, for a simple linked list, how do you identify a simple linked list? So like over here, the linked list structure class, is it? What is that? This is its first node, is it? So once you know the first node, once we know the first node, basically you know the complete list, is it? So it's not an array, it's just a node. The first node, once you know it, then you can through it, go every other node. How do you identify the last node? Okay, second quiz question. How do we identify last node?
The last node, next pointer, the node.
Yeah, very good. Is it? It's next. Is a node. Okay, so be careful. Okay, and you have a first node you identify, and you have the last node that's next point to node. So then you know the complete list. Is it? Okay, so that's the second question. Okay, so you kind of have a picture of the linked list, is it? So linked list is through of the nodes linked together, okay? And then the next concept, who still remember for the nodes, is it for the linked list, you do processing, move from node to node, is it? We call it advance. From first node to second node, and then from second node to the third node, we advance it, is it? So overall, this advance one by one, we call it what? We do node by node visit. The third quiz question. What do we call node by node visit? There is a special word.
Traversing.
Yeah, very good. It's called traversing. Okay, remember this. Traverse. You traverse the linked list. That means you do node by node visit. Because this concept, when we discuss the tree structure, we will use also. Okay, so that's just some conceptual review. Okay, and then next, let's take a look. This linked list, and this example on our course website is called Java linked list, I believe. Okay, it's under comparable. So this linked list, it's a class. Anyway, it's a data structure. Okay, that structure we organize as a class, and T is represents a generic. But this generic has some limitation. So who still remember what does this mean? So what's the limitation for T? What's the limitation for T?
It should be within the borders of comparable interface,
Yeah.
right?
So T can be any object which implement comparable interface. Is it? You still remember comparable? It's an interface. Interface. Is it? Who still remember what's the difference between interface versus class? Who still remember? Anyway.
Interfaces need to be implemented.
Yeah, interface, it has a bunch of methods, and any class implement the interface need to implement those methods. Is it? And hold on, waiting room. Hold on, let me close this, I believe. I need to admit them back. Okay, and then let's go back to. Okay, so hold on. So this means whatever the object, but that object, so that means that class must already implement this comparable interface. Okay, so that's what this part means. And for this linked list class, it only has this single instance variable. This is instance variable. Okay, just a quick review. And then we have a default constructor. Default constructor just create an empty linked list. How do you create empty? So you set the first node to null. Is it? You set first to null. Okay. And the second instance method is empty. Okay. You want to check if the list is empty. So you just check if the first list is empty. Okay. Not a lot of hard stuff. Then let's move on. The toString method we quite familiar. That so the toString returns a string, and for this toString method, because we have linked list, is it? So you're going to output all of the information from the linked list. Is it node by node? That's what this toString does, following certain format that you define. So over here, I use a string. You can use a string builder, string buffer, is it? And you do concatenation, is it? And you see, you get the data part, the information part. So that's what this part, the data means this part, okay, not the next part. And if you recall, when we do linked list traverser, this is kind of traversing, okay, work. So this is linked, and here is the first node, start first node, and you have the data. So here are all data part. And you try to get all of the data output. So over here, we set a cursor. So the loop variable is a cursor. Cursor's type is what? Is node. And you set to the first. Set to first. And how do you advance to the next? And generally, when you do plus plus, but here, no. You set a cursor equals to cursor next. That's called advance. Is it? So let's move to the next node. When should you end? When cursor get to null, then you should stop. Is it? So that's what we generally do when we use a linked data structure to do looping. Okay. And then you get to the data part. Is it? There are two parts. Is it? So this is, this is this part next, is it? And the data is, you get the data part out, okay? And you concatenate together, okay? So that's the toString, not a lot of, and then for insert, for insertion here, we assume we are going to insert in ascending order. But for insert, when you discuss linked list, simple linked list, insert, if you recall in the CS2, there are some cases you need to take care. Empty list. You started with empty list, how do you identify it? First is null. Then you need to create a new node, okay? Create a new node. Is it with the specified item? That's what we do here. Then you assign it to first. Is it? So that's what insert. So this is a special case. And then you can also insert at front. Is it? Because inserting insert in ascending order, is it? And how do you do that compare? And who remembers where this compare to come from? Okay, so this is, I believe this is third quiz question, is it?
4.
Where this dot, why it can call item dot compare to. Why?
I believe it's
Item,
the fourth quiz question.
oh, this is the fourth. Thank you. So the fourth quiz question is, because if you take a look, item type is a generic T. Is it a generic T? So where does this compare to come from?
Comparable
Assuming,
interface.
yes, very good. Which interface? It comes from which interface?
Comparable.
Yeah, very good. Is it? So this compared to defined in what? In comparable, if you recall. Interface. Interface. It's defined there, is it? And whichever class implement that interface need to define your own version. What do you want to compare? Is it? Okay, that's regarding comparable interface. Is it? So that's why you can call. If, be careful here, okay? If I get rid of this, just do angle bracket T, then can you do this? Can you call item dot compare to?
No.
Yeah, then the answer is no. Is it because then in that case, T doesn't support a comparable interface. Okay, here you can do because of you already implement assuming T. Okay, so this is insert at the front. Okay, when you do insert at the front, then you need to set first to the new node. But at the same time, the new node needed to have the original first node as its next. Okay, so that's regarding this special case. And then insert in the middle or back, that's a third case, is it? So you need first to locate where to insert. Okay, so over here it's in ascending order, is it? So that's why we do this dot compare to. Okay, and then here is another question. And what does this return? Cursor dot next. What does it return? Okay, so this is a fifth quiz question. So what does this cursor dot next give you? What's the type?
Node.
Yeah, so it's a node. Is it? It's a node. And then dot data. Is it? That's fine because data is part of node. Is it? And then dot data, what's the return type? Not a return type, what's the type of the dot data?
T.
Yeah, it's T. Is it? Because of its T, that's why you can call compare to. Okay, so be careful here. Okay, so just a reminder. Okay. Okay, and you find it and then you insert it. Is it not a lot of new thing? And we can also do remove, is it, for linked list. And if you recall, there are multiple cases you need to think about. Is it if the first is null, then nothing to delete. You throw exception. Okay. If you want to delete the first node, be careful. If you delete first node, you need to reset first. Okay, so that's about this. And then you're going to delete in the middle, is it? So delete in the middle, be careful when we discuss deletion. Is it suppose you want to like delete this node? Is it? So that's why you have cursor. Is it cursor? And you also have the precursor. Is it? So cursor start at the first, and then here is a previous. Is it? It's a null. And then over here, we do pair advance. Is it? So cursor move to next and precursor, then precursor. Is it? Keep advancing. Is it? Keep track. And once you locate the item you want to delete, is it? How do you delete? You just set precursors next. So you're going to delete this one, precursors next. To what? To cursors next. So this guy identified by this next. Then it's out of the link. Is it out of the linked list? Okay, out of the linked list, the question is it removed from memory? Why I cannot do annotation? Hold on, okay. So is it removed from memory? Here the question is, this node?
No.
Yeah, so it's still left there as what? As some garbage, is it? Okay, so be careful here. Okay, that's regarding remove. And then if you recall for the linked list, is it we define node. Node has two parts, data and the next, is it? And you also have a constructor for the node to build the node. And we define this node class as a nested. So this is a nested static class, okay. Okay, so that's just a quick review for this one. And then let's take a look at the calling part. So the running part, so we first create a string linked list, and you can check if it's empty. Then you just, yeah, please.
Someone send you a message in the chat.
Oh, hold on. Message in the chat, hold on. Let me then first clear this. Stop sharing, because otherwise I cannot get to the chat. Hold on. There are some students I already admit multiple times for some reason. Chat, okay. Chat, chat, where is your, can you resend? Because there are too many messages. Too many messages. Can, who is asking me? Can you just resend the question to the chat?
They did. It's at the very bottom.
At the very bottom. The very bottom just says someone is in the waiting room. I already let everyone in the waiting room rejoin the Zoom. Is that the question?
Yes. Now the Augustine John already John just John.
Yeah, just join. So that's it. Is it? Yeah. For some reason, some new question. Hold on. Okay. New question. Okay, he got back. Yeah. Okay, then let's move. Let's move back. Okay. Okay. So so we have a string linked list, is it? And then you just insert the corresponding string, is it? And you can also do print, is it? Print the linked list. And here you remember, because we do have that toString method, so it will call that toString method of the linked list that we defined. Okay. And over here we also do remove. Okay, so not a lot of new thing here. And then this is for string type. Okay, then next, over here, I create an integer. So can I cross this out to write as this int?
No.
No,
It
the
should be
type
an
has to be a
object type.
class.
Yeah, very good. You still remember. Okay. Yeah. So be very careful. Okay. For generic, the only type you can plug it in is it's some reference type. Okay. Reference type. Okay. So here we have an integer linked list, and then you can insert some number and remove, and you can also output. Okay. So this is just a quick review. This is the simplest linked list, and not a lot of very simple. It just have insert and remove, and can do compare. Okay, supporting compare. Okay, any questions regarding this example? Let me also check. There is another chat question. Okay, you all got it back. Okay. No more question regarding this first simple linked list. Then we move on to the next one. Let me first stop sharing to get back to my example. Okay. The second one, there are too many windows open. Second one, okay. Let me see. And let me reshare. Okay, the second one on our course website, it's called Java Linked List Example 2. Okay, it has 4 files associated with this example: car.java, tclone.java, linked list, and linked list driver. Okay, so maybe first let's take a quick look of the car.java. So let's first take a look at this T clonable. Okay, the T clone, can you see my screen?
Yes.
Right now I'm on the T clone interface. You can see it?
Yes.
Okay, okay, very good. Okay, so this interface definition, you can see it's quite simple, is it? It just extends the clonable, okay? And I define as T clonable. And it has a method, so clonable supports the clone method, is it? And if you recall from CS2, the clonable is helpful for what? We support deep copy. Is that deep copy to avoid a lot of, we call it aliasing problem. Okay, shallow copy. So we already know that concept quite well, I believe. Okay. So anyway, this is T clonable. And then let's take a look at the car class. So the car class, is it implements the clonable interface, okay? And it just has 2 instant name and color, pretty straightforward, and then the car. And then let's see. For the clone method, okay, this clone method you override from what? It's because the clonable interface. Is it? So you needed to, because if you don't implement, then this class is abstract class. Is it? But right now, this car class is concrete class. Is it? Okay, so you create a new car, is it, with the name and the color, and then you return this copy, is it? So in a different memory location, but with exact the same name and color, is it? And my question here, do you still recall? Suppose if here I have another private, suppose it's employee. Okay, E. And if my clone, I just call new car E. Then is this going to be a deep copy, the clone method? If I just implement like this, the question?
No.
Okay, very good. No, is it? Because in that case, you also need to be careful because this is what? Reference type. Is it? But these two are also reference type. But why these two work? With this, then it's not going to work. Who still remember?
String is a primitive type.
Yeah,
Well,
no, it's string primitive type.
It's immutable, my bad. It's
Yeah,
immutable.
very good. It's because it's immutable. Okay, so immutable class. Is it? Okay, so remember, okay. Okay, and this is clone, and the two string, okay, quite simple. And over here, I also override what? The equals method. Is it? And you just do compare with the name, compare with the color. Is it? And who still remember what's the difference between equals? Why you know, a lot of cases I use equal. What's the difference between this equals versus equal comparison? Both are compare. Who still remember what's the difference?
Maybe compare reference and object itself.
Yeah. So this equal compare what? Compare contents. Is it? This what? Compare with memory location. Is it? So this is reference check. Reference compare. This is not a reference, it is a compare contents. Is it? Okay, keep that in mind. That's why over here we want to also override a lot of, for the equals, you need to do override. And okay, then one other question. Then this equals override from who? This equals?
Object class.
Which class?
Is it object class?
Yes, very good, very good. You still remember. From object class. Is it? In Java, object class is very special. Why? Anyone knows? In
Superclass of
OOP,
all classes.
yeah, it's what? Is a root class. Is it? It's a super class. Is it? Is it? Yeah. So basically all other class you created is a subclass of object. Is it? And equals is one of the methods defined in object. Okay. Okay, so that's a quick review of car. Then let's take a look at other way, linked list. And for this time, this linked list, my linked list, I still have the node class, not a huge difference, is it just data next, it's exactly the same as previous. And if you take a close look, okay, this time my linked list, the T, limited by what? By that clonable interface. Then this linked list class itself, it also implements iterable. Iterable is what? Who still remembers what is iterable?
It's a interface and you can use for each loop.
Yeah, very good. So this is an interface. Is it? It supports what? Supports the for each loop. Is it? And the hierarchy is what? Iterable. Then you have collection. Is it? Under collection, we have a bunch of like some list. Is it a lot of things? Is it? That's regarding the generic collection framework. the hierarchy, is it? So iterable is interface, is it? And it's an interface, so it has some method defined, is it? Basically just a prototype of the method list. And anyway, so it's mostly used for what? For looping, is it one by one? Okay, so anyway, be careful, okay? This is the definition for T. And this implements iterable is for the linked list, okay? And then let's see, okay, so for this same thing, we have first as node, is it? And then we have a default constructor, and we have the empty, same thing. Okay, for the insert over here, I define a little bit, I call it insert after. So I'm going to insert a new item after the specify item. Okay, after specify item. And you still have a number of 3 cases to consider. Insert for the empty list, the insert at the beginning and insert in the middle, 3 cases, is it? But be careful, you're going to insert a new item after this item, is it? After this item. Okay, so you needed to find the item. That's why over here I call the equals. Is it? I don't need to, I just want to find the contents, not the memory location, is it? Okay, so once you find the item, then you can insert after it. Is it insert after it? So here is how you insert after. Okay, so it's pretty straightforward. Okay, so we are now going to line by line analysis because there are some other important part here. And for the remove, it's the same thing. You need to find the item and then you remove it. Okay, so similar as the previous one. Not a lot of new thing. Okay, and then here for the contains. The contains. And the contains is basically just a search. Is it? You search if the specify item in the linked list. Okay, then pay attention here. Over here, what is this kind of loop? Just a review.
A for each loop.
This is, yeah, this is our for each loop. And what is this special thing? This. What does this mean?
It references the object that you're using.
Yeah, what is the object here?
The
The
linked list.
Yeah, very good. So this refers to the linked list object itself. Is it? Itself. So basically in main, is it if you have some linked list, suppose car, L car, suppose you call, and then you do initiate, is it? And basically that this, in this case, then is the L car. And if you have linked list L car 2, then it can be L car 2. Okay, it refers ref object itself. Because over here, it's just the definition of the class. There is no object there. The object you need to create, you need to call new, etc. So this just generally speaking represent object itself. And here you can, so here I use for each loop on linked list, Y. Let me see. So I don't know why it's not working. Let me hold on. Okay, let me clear. Sometimes the annotation got stuck. So Y over here, I can do Y for each loop. Legal here.
Because we implemented the iterable interface.
Yeah, very good. Because this specific linked list implements that iterable interface already. Is it? Okay, that's why you can. If not, then you cannot do this kind of loop. Okay, so this is quite efficient. Okay, here. And then you just call compare. As that you try to see over here, we don't do equal. We call this equals because you just care about the contents. Okay, you don't want to compare the memory location. Okay, so that's the contain and the get method. So the get method just find the number 1 item, number 2, number 3, etc. You specify the item and you can return the contents here. Okay, so over here you do the advancing, etc. Cursor advancing, and did you see you return over here? I call the clone. Is it why I can call clone? Because data implements the T clonable interface. Is it? That's why here you can call the clone. Okay. Okay, this is also the 2 string. Then same thing I use for each loop. Then concatenation string buffer, string builder. Okay. And over here, for this specific linked list, I also override the equals method for this specific linked list. And this is because later on when we learn hashing, we will have the concept. Okay, so generally speaking, whenever you override the object's equals method, you need to take care of these 3 parts. First, make sure the parameter object type is not a null. Okay, so you need first to do this if cases. The second, you need to make sure both objects here are the same class type. Okay, so you call the get class to make sure. In the past, in our CS2, we kind of don't worry this, is it? But starting from the CS3, because later on, we will get to the point, okay? Make sure each time after you write equal, do what like this example show, complete this 3 part, okay? 3 cases. So now compare the class type, compare, and the last is because this is a linked list, so you need to do each node by node compare. You just compare the data part, okay? Do node by node comparison, okay? To see if 2 linked lists are the same. But here, be careful. What we mean, the 2 linked lists, you mean this 2, you mean their contents. Okay, contents from each node, okay, is the same. Not a memory location, okay. Memory location, that's a different story. So here's memory, so it points here, it points here, etc. Then that's an equal case, okay. So be careful here. So what here we care about is the contents. And the copy list, so this is a deeper copy of the linked list. Is that you do node by node copy and you can read it. So not a lot of new things here. The focus here, because this example regarding the, not to compare, the iterable interface. Iterable interface just has this single method called the iterator method. Iterator method returns type is what? Is an iterator. It is an iterator. So you need to override this method, return an iterator. And who remembers what an iterator is? Iterator is a class. So concrete class or abstract class or interface. Who remembers? What is that iterator?
It is an interface.
Yeah, it's this one. Okay, so it is an interface. And if it is an interface, the question is, can I do new iterator? Can I call new iterator?
No,
Yeah, you cannot do that, okay. Interface and abstract class, no new. Okay, no new, okay. New is what? Only apply to concrete class. Okay, concrete class, so you cannot do that, is it? Okay, but here it says, oh, you can, because, but it's a type, the type is an interface. Why the return type can be an interface if you cannot do new?
because we create a class implement iterator interface.
Mhm.
So we can return an object of a class that implements iterator interface.
Yes, very good answer. Okay, so this is also part of object-oriented programming, is it? Yeah, so there is some word who still remember some technical word regarding this kind of cases.
Polymorphism, is it?
Polymorphism, yeah. And related with polymorphism, there another technical word. Just some technical word regarding, or words regarding this kind of cases. DYN.
Dynamic binding.
Yeah, dynamic
Yeah.
binding. Okay. Yeah, that's why you can do this. Okay. Okay, polymorphism. Yeah. So, and then what is this new linked list? So you define a class. This is an inner class. And this class, because it implements the interface. So that's why here it works. Is it? So even though the return type is because it implements that iterate. So that's why this works. Okay. So anyway, this is a class. It implements iterator. And the iterator is an interface. Within iterator, it has 3 methods you need to override. Is it? Whenever you override this interface, has next, next, and remove. So each time, if you define a class that implements this specific interface, you need to provide your version of has next, next, and remove method implementation. Okay. Okay, I think we run out of time today. Okay, so let's just stop here today.